Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem middle of the linked list. So the problem statement says that given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. So basically we are just given a linked list, head node is given, and just we have to return the middle of that linked list. And if the length of that linked list is odd, we can just return the middle. And if there are two middles, for example, if the length of the linked list is even, so we can find that two middles are there. In this case, in example 2, 3 and 4 are two middles, so we have to return here the second middle, it is 4. So we have to just do this. So what could be the most brute force approach? The most brute force approach which can come into my mind is we can go to each and every node until to the last and just check what is the size of that linked list. Suppose the size of linked list comes to be n. So if the length of this linked list is odd, we can just again iterate till we get a size. We can use a counter, and we will iterate to the linked list until our counter becomes n by 2. Alright, because 5 is here, so n by 2 plus 1, 5 by 2 will be 3, 5 by 2 will be 2, and the middle will be plus 1. So we can use a counter, and whenever counter reaches n by 2 plus 1, we can say this is our middle. And in the second case also we can see that we can traverse to check the length. So if length comes n, we can just say use a counter and print n by 2 plus 1. This will give the size is 6, 6 by 2 will come 3, 3 plus 1 will come 4. Alright, this will come 4. So this will give the second middle of the linked list. So this way, first of all, checking the size of the linked list, iterating all the nodes will take time complexity of big O of n. Second iteration to just find the middle one, this will take time complexity of big O of n by 2. So the total time complexity is this. This is big O of 3n by 2. But and space complexity is big O of 1, but we can optimize this using slow and fast pointers, that tortoise and rabbit pointers, slow and fast pointers. What we will do, for example, we have, let's do this on two types. One is there, two is there. I'm going to explain this first through a odd size linked list, and secondly through a even size linked list. So we can just use slow and fast pointers. Slow and fast pointer will be initially pointing to head, that is start of the linked list, that is 1 here. And we all know slow pointers jumps by 1 node, and fast pointers takes 2 moves, jumps by 2 nodes. So in the first, slow and fast pointer will be here, and next the slow will move by 1 and fast will move by 2. Next, slow will move here, fast will jump by 2, this he will be here. So now whenever in the odd case, we can see if the fast pointer has reached the end node, that is we can say that fast pointer's next has became now null. So we can say that if fast pointer has reached the end node, we can see that slow pointer is at the middle of the linked list. So we can say that 3 is our middle node. Alright. Now in the odd case, we will again use slow and fast pointers. So initially slow and fast pointers will be here. Next, in first iteration, slow will move here, fast will move here. Next iteration, slow will move here, fast will move here. In the next iteration, slow will move here, and fast will go out of bound. So in the even case, we can say that if fast is equal to null pointer, we can say that the node where slow pointer is there, we can say that this node is only our second middle in the even size case. So just using by this slow and fast pointers, we can just uh, use a temporary node to run across, not a temporary node, we can just use slow and fast uh, pointer nodes to run across the linked list. And whenever these two conditions reach, we can say that we'll just return our node, slow pointer node. Alright, now I will go to implement this. So what I said, first of all, I will declare the nodes. So one will be my slow and another will be my fast. While what were the two conditions? While fast is not equal to null pointer and fast of next is not equal to null pointer, we will just keep moving fast and slow pointers. Fast will be fast of next and slow will be just slow of next. Now whenever this loop will end, we can just return the slow pointer and this will give our required middle node. So if I run this, is there any problem? Let me recheck. While fast is not is equal to null pointer, or okay, I have not initialized them. These were pointing head initially. So if I run this now, I hope this will pass the sample test cases, and if I submit this question we can see is solved now. And if I talk about the time and space complexity, so time complexity, we can say that initially that was big of 3 n by 2, and this time we can see time we are just moving whenever our fast pointer is exhausted, we can see that we are returning our answer. So fast pointer is moving 2 times, so we can say that time complexity is big of n by 2. So we have reduced our time complexity from big O of 3 n by 2 to big O of n by 2, and where n is the size of the linked list, and space complexity we are not using any space, so we can say that this is big O of 1. So we have solved this problem successfully now, and this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.